Hey guys, in this video I'm going to talk a little bit about one-to-one functions and inverses. They're actually very related. Let's start just by looking at these relations A and B. And I've given these relations names. This one's called F and this one's called G. One of the things we talked about is how to determine if a relation is a function. So this part's a little bit of a review, but hang in there because we're gonna build on what we know. Okay? If you take a look at this guy, you'll see that there's repeated y's, but that's okay. The definition of a function is that each input is matched to exactly one output, and that's the case. 0 matches to one output, and 2 matches to one output, and 5 matches to one output. So this guy is a function, okay? And let's look at this one, okay? 5 matches to 2, 3 matches to 1, and 8 matches to -9. So these are both functions, but there is a distinction between them because this guy right here has a repeated y. Now that doesn't change the fact that it's a function, but there's a special name that we give functions where it has unique y's. So kind of what I would, a little note that I would make to myself here is that this has a repeated y value, and this one has no repeated y's. Okay, so again, still both functions. This one is special because it has no repeated y's, or in other words, all the y's are unique. So another way to say that is unique y values. Okay, this one is what we call a one-to-one function. Okay, so they're both functions, but this one's a special kind of function that we call one-to-one because it has unique y values or no repeated y values. Okay, now let's take a look at what an inverse is. We talked about this in class today, but if you missed that or if you just need another example, we can talk about that here. Okay, first of all, let's talk about some notation. So this little guy here, this little -1, this looks like f to the -1 power, but this is actually, how you would say that is f inverse, or the inverse of f. Okay, and how you would say this is g inverse, or the inverse of g. Now since I named my functions over here, I can kind of use the letters to match up the functions. So f inverse means look at the f function and then find its inverse. Okay, so f inverse is the inverse of the f function, and what we do to get it is we're just going to switch the x's and y's, the x and y coordinates. Okay, so we're going to go 3, 0, and we got 3, 2, and we got -7, 5, right? So that's the inverse of the f function. Okay. Now notice that this guy has repeated x values, right? The original function is a function and it had repeated y's, but when we switch the x's and y's to get the inverse, we end up with something that's not a function. So this is the inverse of f, but it's not a function. Okay. Now let's find g inverse. Okay, again, to find the inverse of a function or a relation, oops, curly brackets don't look so good there. You're just going to exchange the x and y coordinates. Okay, so here's the g function. I've named this guy g, or it's a function and it's a relation. Let's swap the x and y values. Okay, now notice because I didn't have any repeated y's, when I flip this around, this is going to end up being a function because each input is matched with exactly one output, right? 2 is matched with 5, and 1 is matched with 3, and -9 is matched with 8. But here, the input 3 is matched with more than one output. So the relationship here is if you have a function that is one-to-one, its inverse will also be a function. If you have a function that's not one-to-one, when you try to invert it, you will have something that's not a function anymore because the repeated y's will become repeated x's and then your inverse won't be a function. Okay, so this is kind of the key idea there. If a function is one-to-one, then its inverse is also a function. Okay, now every relation has an inverse, and the inverse of a relation is also a relation. Okay, But sometimes when we take the inverse of something, we get something that's a function, and sometimes it's not a function. Okay, so this is again the kind of the rule. If a function is one-to-one, then its inverse is also a function. Okay, now there's another test to see if something's one-to-one. What we did is we just looked for repeated y's, right? Repeated y's was our test. So repeated y's, not one-to-one. If there's no repeated y's, it's one-to-one. There's another one-to-one test that you can do on a graph, which is called the horizontal line test. And I've posted a video about that also. So if you're interested in kind of how do you do it from a graphing perspective, how can you test if a function is one-to-one from a graphical perspective, you can check out that video next. Thanks.